We are live. Hi everyone, welcome back to Codera. Today in this video we'll be discussing the LeetCode daily challenge for 2nd of February. The name of the problem is find all anagrams in a string. So this is the problem. Previously this problem has been asked in a lot of organizations like Google, Uber, Microsoft, Amazon, and it has also been asked in PayPal, right? So we'll be discussing this problem. So consider giving me a +1 in the chat if my voice is clearly audible to everyone and my screen is visible, and then we'll start with this particular problem. And like this is a very easy problem. It's based on the concept of sliding windows. Okay, hi Abhinav. Right, so I'll be discussing this problem with you, but before starting, if you are new to the channel, so you can consider to subscribe this particular channel, because on this channel, like I am doing the LeetCode daily problems, daily challenges live stream for the past 21 days without a break, right? So that's a habit. So you can consider, if you want to see the solutions for that, if you just want to keep solving one problem per day, so for that purpose you can follow our channel. Apart from this, we are also putting codeforces editorials and a lot of other things, so you can consider to check out our channel. Now let's come back to this particular problem. So hi Yogesh. Right, so the problem name is find all anagrams in a string. Now the first thing is, what is an anagram, right? You have to find all the anagrams that are present in a string. So first of all, what is an anagram? We'll be discussing this as well, right? So you will be given two strings. You will be given S and P, and you have to return an array of all the starting indexes of P's anagrams in the string S, right? So you may return the answer in any other. That is something that we'll be discussing. But let's see what is the definition of the anagram. An anagram is a word or a phrase which is formed by rearranging the letters of a different word or a phrase, typically using original letters, right? Exactly once. So what does this mean? So if I say that if I have something like if I say that I have something like a map, right? So if I have a map, then let's say PAM, PAM. If this is the word that I'm making, so both these words are anagrams. Why? Because the frequency of M is equal to 1, the A is also occurring one time, P is also occurring one time, right? So this is an anagram. Like, let me take some more examples. So if I say that I have something like let's say DAD, dad, right? DAD, dad, and if I write it as ADD, add, right? So number of frequency of A is here 1, frequency of D is 2. Here also the frequency of A is 1 and the frequency of D is 2. So these two are anagrams of one another, right? Like if I have to take another example, so let's say if I take God, right? If I take the example of God, hi Vanshika Kapoor, if I take the example of God, then you have one time G, you have O one time occurring, you have D with the frequency 1. If I write DOG, dog, right? So this is also D is occurring one time, O is occurring one time, G is occurring one time, right? So both these are anagrams, right? These strings are anagrams. And I want to tell you that anagrams, questions related to anagrams are asked a lot in interviews, especially companies like Microsoft, Amazon, and like these companies, all these companies are a lot, they keep on asking these questions based on anagrams a lot frequent, right? So let's start with this problem. If the definition of anagram is clear to everyone, you can just give me a +1 in the chat, right? So now what they are saying is, they are saying that you will be given a string S. Let's say they give you a string S. Let's say I give you a string S. Let's say it is nothing but CBA, then let's say ZXY, and let's say BAC, something like that, right? And they have given you another string that is P is equal to, let's say, ABC, right? So you have to tell that what are the anagrams that are present in this particular string, right? So if I see ABC, so A is occurring one time, B is occurring one time, C is occurring one time. So you have to return what? Let's see, let's check out. So you have to return what? You have to return an array which is consisting of all the indexes of P's anagram in the string S, right? So if I will say, if I will look at this particular question, let's say I have one few more additions to this string. Let's say PQ, and let's say I have after that let's say BCA, something like this, right? So what I can do is, I can see that if I start from here, if I start from this particular index, so from here until here, I can see that I am getting one anagram. That is, for ABC, one anagram could be CBA, and it is starting at the index 0, right? It is starting at the index 0, right? Another anagram that I could have is this anagram, right? it is also of the same size. First of all, the size should be same, then after that the frequency of all the characters should be the same. This is the typical thing that's required. If you have BAC, right, if you have BAC, then BAC is also an anagram. Why? Because ABC, BAC, like all these characters is occurring exactly once here and here also, right, and the size is same. So this anagram, let's say I make an indexing, so this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, right? So this is the indexing 6, because from 6 also another anagram is starting, right, which is this anagram, right? So this is starting from the 0th index until the second index. This is going from the 6th index till 8th index. So I have to return the first string. Hi Shreya, hi Aryan, right? Now next up, if I'll see, so 7, 8, 9, 10, 11, 12 and 13, right? So I can see that this is another anagram, right? BCA is also having B one time, C one time and A one time. So this is another anagram of this particular given string, that is ABC, and it is starting from this index 11, right? So I'll write 11. So in the vector I'll return 6, I'll return 0, I'll return 11, right? What are these indexes? These indexes are the nothing but the starting point of the anagrams in this bigger string S, right? Is this part clear to everyone? If this much part is clear, consider giving me a quick +1 in the chat and please like the video so that I can move ahead with this question, right? Okay, if this much part is clear, if this much part, like what you have to return in the answer, returning in the answer, why we have to return a vector, and what we have to return in the vector. In the vector we have to return the indexes, starting indexes of all the anagrams that are present in this particular string S for the given string P, right? This is what we have to do, right? For example, for ABC, you have this anagram which is starting at 0 and it is the anagram of ABC. This anagram starting at 6, it is also an anagram of ABC. This substring of size 3, BCA, it is also starting at the index 11, so it is also an anagram. So I have to return 0, 6 and 11, right? It's clear to Ramesh. What about others? You can also let me know. Others can also let me know, right? So this is the question part. Now to do this problem, right, let's take the original test case that has been given to us so that things are much more clear, right? I took an example for you, but let me now look at the test case. So if I have CAE, let me just copy this particular test case and then I'll show you. Okay, right, let's copy this particular test case, right? Okay, so it's not visible, right? No problem. I'll copy it. CBAE, CBAE. Okay, so let me write it. CB, then AE. Let me check what I have. CBAE, then I have BA and CD, right? Then I have B. Oh, sorry. What is happening? Just give me a second, right? So this much part is clear. Just give me a second. I don't know what happened. Okay, right. So what do I have in the string? Let me check again. So I have CBAE, right? I have CBAE. So I'll first write C, then I'll write BAE. Then I think I had something like CBAE, then BA, right? BA. Again, there's a problem, right? BA, and then I had what did I have? I had CD, right? I had CD. Right, this was the string that I had, and the string P that has been given to me is ABC, right? P is given to me as nothing but ABC. P is equal to ABC, right? P string that has been given to me is ABC. Now I have to find all the anagrams of this string, right? So first of all, let me mark the indexes. So this is nothing but index 0. This is 1, this is 2, this is 3, this is 4, right? This is 5. Sorry, this is 5, right? This is 6, this is 7, this is 8, and this is 9. So if I will check, so I can say safely that this particular string is an anagram, and CB, like for this string ABC, CBA is an anagram, right? And it is starting at the index 0. So I'll say, okay, this is one of these strings. Now I'll check, is there any other string? So here I cannot find any other string. Here also, if I will look closely, so this also seems to be an anagram, right? BCA, right? BCA is also an anagram, which is starting at the index 6. This BAC, the string which is as known as BAC, it is also an anagram of ABC, right? So these are the two strings that are starting. One is starting at the index 0, another is starting at the index 6, right? So if this much part is clear, you can give me a +1 in the chat and also like the video if this approach is clear, right? Answer is clear, because like this is the actual answer for this particular problem, right? Yeah, so you can see that you have answer 0 and 6, right? So like if you had if you have this thing, right? So what can we do? Can I say that I need to check? Can I say that if I have to check for this particular problem, please give me a +1 in the chat if up till now things are clear to everyone, right? Now in the question, can I say that if I have been given P is equal to something, right? P is equal to something and S is equal to a something, right? A bigger string. Can I say that if I have to check, so what I have to do is I have to check for all the substrings, right? Check for all the substrings, right? Of S, right? Check for all the substrings of S, right? I have to check for all the substrings of S which will be of size, let's say the size is M, right? Let's say P is having a size of M, right? If P is having a size of M, then if this is the string that has been given to me, right? If let's say I had ABC, right? If P is equal to ABC, right? If P is equal to ABC, then what was the size? M would be equal to 3. So I'll, in the string S, this is the string S. So in this string S, I'll check for the first 3 characters. Then I will check for this from this index till this index, right? Then I'll check from here till here, right? Like this, right? First of all, I'll take this much. Then what I'll do? I'll take this part, right? This substring, right? Of size 3. Then I'll be taking this particular substring of size 3, right? Like this, I'll be checking every substring of size 3, right? So what I'm saying, I'll be iterating from the ith character, like I'll start a loop for I start from 0, I is lesser than, let's say, n and I plus plus, right? What I would be doing is for let's say j starts from I, okay? J is lesser than nothing but, let's say, or you can say, like, you can have a counter or you can have something like that. J is lesser than p plus size, right? Something like this. And then j is lesser than n also, right? You need, since you need to keep a check, so you will generate all the substrings, right? What you are doing is basically generate all substrings of size m, right? Where p, the string p that was given to me, its size is m, right? Its size is m. So you generate all the substrings and then you check that whether that particular substring that you have generated, if it is having all the characters, if the frequency of all the characters that are present in the string, if it is same as the string that you have or not. Like, let's say if you had something like let's say ABC, if you have ABC, right, and you have BCA, if you have made BCA as the substring, then you check that whether B is occurring same number of times, C is occurring same number of times, A is occurring same number of times or not, right? All the characters are occurring same number of times or not. So if you will do it this way, so it would take something like order of n square or more, because you will be also checking the frequency, right? To generate all the substrings, it would take order of n square. Now this approach is a little bit time consuming, right? So what we could do with this particular question is, you can easily observe from this question that this question is nothing but a sliding window concept, right? Because what we can do is, we have to always slide our window, right? Our window has to be slidden in such a way that we always end up generating the substrings of size m, right? Let's say if I give you an example, so if I have a b c, right, if my p is given to be abc, and if I have, let's say, I have something like x y, then I have a c b, then let's say I have z, I have, then let's say b c a, then something like this, right? So what I could do is, I could have, first of all, have this much, right? Then what I can observe is, the next substring that I'll be having is this substring, right, of size 3, this substring, right? Up till, like, from the starting, I can observe that this would be the substring, right? This would be the substring, right? This would be the substring. But now what I can observe is just one character. If I shift by one towards the right index, if I just shift by 1, right, then I will get a new string, and I'll just leave the previous string out. Like, I'm just leaving the previous string out, like previous character, like this character I'm skipping, this character I'm not considering, and this new character I'll consider. And in this case, I'll have windows of size m, right? Is this much part clear to everyone? Please give me a +1 in the chat if this much part is clear to everyone. Is it clear to everyone, right? Is it clear to everyone? Okay, so this is what you can do. Now with this particular question, the thing is that how will you count for all the substrings, right? How will you count that whether for all substrings you are like how you are checking, right? So what you can do is, you can have, let's say, a vector, right? You can have a vector, like you can have a vector of size 26. size 26, where all of the indexes would be initialized to 0, right? All the characters frequency would be initialized to 0. This will be for the string p, right? And you can have a vector that is for string s, and you can, let's say you can name it as a map or something. It will be also 26 size, right? And all of them would be initialized to initially 0. And what you could do is, you can every time you can do what, you can check, you can first of all have the frequency of p, right? P's frequency would be constant. So let's say if you have a b c, right? So you can mark that the frequency of a is what, a minus a would be nothing but 0, right? B minus a would be nothing but 1, right? If I have c minus a, so c minus a would be nothing but 2, right? This like this. So what I could do is, I can store the frequency of p, right? I can store the frequency of p in this particular vector. Then I can keep on checking, right? If I am at a particular character, right? Let's say if I am at a particular like at a particular character, so what I will be doing is, I will be checking for the window of size 3, right? That window of size m, that is the size of the string that has been given to me. So what I would be doing is, like, if let's say I have, let's say a b c is the given string, right? And if I have x y, let's say a and b and c, right? So what I will do is, let's say in the vector v, a is one time, b is one time, and c is one time, right? So that means that the index 0 is 1, index 1 is 1, index 2 is 1, because I have represented it like this, right? A minus a would be equal to 0, b minus a would be equal to 1, and c minus a would be equal to 2, like this, right? What I will see is, if in this particular window, when I will be having the map for the current string, so it will indicate that x is one time, y is one time, and a is one time, right? So what I can do is, if I have, let's say this is the vector 2 I am having, so I can, in C++, I can simply compare vector 2 equal vector 1. If both the vectors are having the same frequency of elements, in that case it would return true, right? It will get true in the if part. And if both of them are equal, then I will simply store the index, right? Simply store the index. Let's suppose that if I was at this particular index, right? Let me just show you like what would happen if, let's say, if I had let's say something like abc, and let's say I had bca, then xy w, something like this, right? So what I'm saying is, this much particular window I'll be having, right? So my I would be here. What I'm saying is, this index is 0, this index is 1, this index is 2. So my I value is what, you can easily see that my I value is nothing but 2, right? My I value is 2. And what is the index at which I am starting? I can see that the index that at which I am starting is nothing but 0, right? So the index at which I am starting is nothing but 0. So what I can do is, I can say that I plus like, if you will try to see, right, if you will try to see, then what is the index that you will be inserting? You are at the index 2, so what will you insert? So what is m? M is the size of the second string, right? M is nothing but p dot size. This is string p that has been given to me, for which I have to find all the anagrams, right? This is string p, right? So what I will do is, if I say I minus p dot size, so what will I get? If I do I minus p dot size, then in that case, if I have I is 2 and p dot size is 3, so I'll get -1. But actually the index at which my anagram is starting is 0. So that is why what I will do is, since the indexing is 0 based, so that is why what I need to do is, I need to do I plus 1 minus p dot size, and that will be the starting point of my every anagram. That if there is an anagram till this index I, then the starting index of the anagram would be I plus 1 minus p dot size, right? So I'll keep on storing all these answers in my vector, in my resultant vector, or in my resultant vector I'll simply push back this result, right? Is this much part clear to everyone? I hope that it's clear, right? It's clear to Shreya. What about others? Others are also clear with this part, right? So this is what I would be doing. Now let's say if I move to the next thing, right? Basically we are checking vectors, and if you are checking vectors, if vector 1 is indicating for the string p, so it is of size 26, right? Vector 2 is of size 26 as well. So if you compare vector 1 equal vector 2, so it will just take a time complexity of nothing but order of 26, which is constant time, right? Which is constant time. So that is why the overall time complexity would become order of 26 into n, which will be very close to nothing but order of n in case if the n value is very large, right? So this is what would happen. Now let's say if you are moving to the next character, right? If you are moving to the next character, then what will you say? What will you say if you are moving to the next character? If in this particular given string, let's say you are moving to the next character, right? If this is the new window, right? So this was the this was present in your string. So what you'll do, you will say that vector of 2, from this vector of 2 you have s of I plus 1 minus p dot size, that is this particular index. You will be removing this frequency b, right? You will say that okay, if you have left this particular string, then its frequency is getting removed, right? So you will say that I plus 1 dot size minus minus a, that this particular character minus minus, you will subtract its frequency because you are leaving this particular character, and this is one new addition that you are doing. So you will say that v2 of s of I minus a plus plus, right? Why you will do this? Why you will do this? Because this new character is getting added, right? So you will add its frequency, you will increment its frequency in your map of this particular string, right, of this particular window that you have of size m, and for this particular string you will be removing it. For this particular character you will be removing it. Why you will be removing it? The reason for removing it is very much simple, because you do not want it to be present, because you are sliding your window, right? You are moving by next, like what you were doing initially. What you were doing, if I, let's say I give you xyz, if I give you abc, something like that, right? So you were doing like that, okay, xyz, then yza, something like this, right? But I am saying that you just slide your window by one. If you have this thing with you, right, if you have this much thing with you, then you just move one step ahead, you just leave the previous, and in that case your window size would remain the same, and you can check for every. Why adding a? Which part are you saying? Why adding a? Why adding a? I'm not adding a. Are you talking about this part? Like if I have a particular string, let's say I have bca, right? So what I'm saying is v2 of, if let's say I'm at this particular character, if I is here, right, if suppose my I is at this particular index, so I will do what? I will do s of I minus a plus plus, right? This is what I would do if this string is s, right? If this string is s, then this is what I would do if I had to increment, if this character is there, right? If let's suppose that this was the character, but if I have to move to the next character, right? So let's say like if I had a character, maybe if I move to the next character, right? If let's say I have a z character, right? So if this is the new window that I'm having, so if my I is standing here, then I will do this to increment the frequency of z. So I'll say that okay, c is occurring one time, a is occurring one time, z is occurring one time, but b is also occurring one time, but I have left this particular window, so that's why I'll mark its frequency to 0. So I'll mark b to 0. That is, I'll decrement its frequency by 1. So what I would do for this, I would do v2 of s of I plus 1 minus p dot size minus a, right? This is what I would do, minus minus, right? So I'll decrement its frequency. Let me show you the code part. It's very simple. First of all, let me show that my code would be working, right? Is this much part clear to everyone? I hope that it's clear to everybody. You can see that like code got accepted. Now if you will look at this particular thing, so what you will be doing is, first of all, you iterate through the string p, you mark your goal, that is the goal frequency that you want to have, that is the frequency that you have with respect to the anagram. So in your goal you mark it, right? So for every character you increment. For the string p, you first of all build that what is the frequency of every character, for what is the frequency of all the 26 characters in the vector in the given string p, right? Once you have done that, so what you do, you start to iterate through the original through the larger string s, right? And what you do is, if you are at the current character, if you are at the new character, so you just simply add it, right? If you are at a new character, so you just simply add it. And if your size is greater or equal to p, right? If your size has become, if the I has become greater or equal to p, so that basically means that if you are moving one index ahead, right? Initially, like if you are here, right? Let me show you this part. Just give me a second, right? If what I want to say is that, let's say if you are something like this, if you are, let's say x, y, z, and let's say a, b, c, something like this, right? So if you are here initially, so in that case, will you leave? No, you will say that x frequency is 1. Then you will say that okay, if the p dot size is 3, right? If the p dot size is 3, so I is 0, I is 1, I is 2, right? So you'll say okay, this. So you'll say y is 1, you'll say z is 1. Up till here you will not decrement anything, right? But once you reach this particular mark, right? Once your I reaches a point such that I is greater or equal to p dot size, in that case you are adding this particular new character, and now your window size should be 3, right? Your maximum characters that you can have is 3, so the substring can be of size 3. But here you can see that if you will add this a, so the substring would become of size 4. So that's why you will decrease the leftmost, right? You will decrease the leftmost. So that is what you are doing. You will remove the leftmost frequency. So that is what you are doing, right? This I minus p dot size and minus a and minus minus. So you are decrementing its frequency. Then you are checking that if the frequency of the all the current characters is equal to the frequency that you want in the character p, then in that case you simply push the index, right? That is, the index is I plus 1 minus p dot size. So this was the problem that was asked. So this problem, as I said, was asked in a lot of companies. Like it was asked in Google, it was also asked in Microsoft, it was also asked in Amazon, and a lot Uber also. So a lot of companies. So that's why you can try out this problem. I'll attach the code for this particular problem in the description. If you want to say anything, then I'm still here for 60 seconds. If you want to say something, then you can say. Otherwise, I'll end this particular stream, right? If there are any questions, then you can ask. Feel free to ask those questions. If anyone has any question, like Shreya, Aryan, Mahesh, or anyone else, Yogesh, Abhinav, anyone is having any questions with me, so they can ask. Otherwise, I would end this stream, right? So this was the question. You can try this out. Apart from this, you can check out the channel. Like if you like the content that we are publishing, so you can